Hello YouTube, this is Ready Set Exploit, and we're going to be doing profiles from TryHackMe, which is a challenge I created that is about Linux memory forensics. So we're given this zip file that contains a Linux memory dump, and typically we can use Volatility, but we need a profile which is not given to us. So Volatility uses the profile information for Linux so that it can parse the system. The challenge here is to be able to create a profile from the memory dump that we have. It's actually it's pretty cool, and the history behind this is when I was working on the Advent of Cyber 2023 day 19, I asked myself what would happen if I didn't have the profile. And then this led me to creating this challenge. So this challenge is actually almost divided into three parts. The first one is installing Volatility properly, and I'll go over that, an article that I found, and then a script that I wrote that pretty much just automates the steps of that article. Then is creating a profile, and then from there it's just doing basic analysis. So without further ado, I'll go ahead and get started. I already downloaded my zip file here, so I'm just going to extract it, and that's going to take some time. So first thing is, while it does that, is let's look at installing. So one article, and this is actually in the room task. I provided a link because there's so many ways to install Volatility, and unfortunately if you install it wrong, it could cause problems for you. So I think this article is by Sean the Geek, and it goes into detail how to install 2 and 3 on Debian, Ubuntu, or Kali Linux. So it tells you install the system dependencies. We need pip for Python 2. Then install Volatility 2 and this dependencies, pip for Python 3. Then the same thing here, Volatility 3 and the dependencies. Then it tells us how to set out a path. So if you're using Kali Linux, see, it's a pretty short article, but if you're using this ZSH, it tells you how to kind of export it if you already have it. So this is mine to go to whenever I need to install it, and this link is provided. But if my profile as the creator is there, and if you go to my repo, repositories, and if you look through this, I do have a script as well. This one I didn't provide on a task. I didn't want to kind of self-promote on the room itself, but see, the original post is from here, and you just run it as your user as root and how to use 2 and 3. So for this one, I'm going to clone this, and this should be ready. There's the memory dump. Go into this. So git clone. There it is. Go into it. And I always like to, I already took a snapshot, but I always like taking snapshots of my system whenever I install something new. So I recommend doing this here. So we're going to go ahead and install it. Enter password. And some stuff needs to be root, some stuff doesn't. So while that runs, let's go ahead, go over it. So starting with this function, this is basically the dependencies. We do a quick update. We installed the dependencies we saw earlier, and then the Python dependencies, right? And then from there, we also do the same for Python 3. Then it installs Volatility. So see, user is who am I at that moment. For this one, I installed it locally. See, so curl this, install it, remove it, install these two, then install this. And I didn't install Yara. I used to have it, but it seems to cause issues with newer versions of Python. Then I do this, and this was for Yara as well. So I haven't used this recently. Every time there's a new update on Python, it just breaks Yara. The rest works, but Yara seems to not always work. So I don't have it there by default. And then I just kind of repeat the steps. This little line is not on the installation part, but there's seems to be something with this library here that we need to change this into this, otherwise you get an error. So that's just what that does. That's pretty much the script, and it's done pretty quickly. and now we can try it, right? So I'm gonna get out of here, go out of here, and let's see, we have our memory dump. It doesn't tell us what it is, it's just data, right? You can use strings on it to kind of get an idea, but let's see if Python installed. So let's do, well, this is Python 2, and install properly, Mac, this is usually for Windows, have our Linux commands here, we're going to use some of these, and scanner checks, address spaces. So if you sort of remember, if you did happen to do admin of cyber, then I kind of went over it quickly. Profiles, right? What volatility uses to parse, to analyze, to help analyze the memory. All these windows are here, right? But Linux, because Linux is so vast, so you know, there's different configurations for each. It doesn't come with a default one, right? There are some on the, I think, the GitHub repo for both for Linux, but typically when you create the memory dump of a Linux server, of a Linux memory dump, you also create the profile right there on that at that same moment. So it's pretty much how that analysis will go. But the challenge here is we don't have it. And if you wanted to try out Volt, just do Volt. That's, according to my script, that's basically Volatility 3. See? So we're going to do mainly Volatility 2 and one command of Volatility 3. So let's go ahead and call this Volatility 2. Definitely Volatility 2. There we go. Call that 3. Okay. So we don't have a profile. What can we do? So could do a quick search for create profile for, I'm screaming, create profile for Volatility Linux. 2 articles, and this article was also on Admin of Cyber 2023, day 19, and let's see if that comes up. Advent of Cyber 2023, TryHackMe. I'm gonna get a lot of videos, but there we go. You can see this, it's public. So let's see, that loads, loading, day 19, there I am, crypto miner saying blah blah blah, volatility, animation, and scroll down and go right into the profiles, and I'm giving you a lot of the same commands, how to, and how, you know, this was already provided, but in here, see where it go, right there's a little article, and the reason why I clicked on this one is because this kind of goes over what I said, right? How to sort of create the profile. And this is all that great article by Andrea Fortuna that kind of goes over a lot of volatility things. This is the one we're looking for. So kind of goes over step by step on how to do it, right? So it gives you even the commands. So it goes, we need to get the kernel version. Volatility 3 allows us to do this. So vol Linux, I guess need banner, and let's see, it should go, and we get it right away. So we have a Linux version 5.46, here's the kernel version, and it even tells us the distro, and this is going to come in handy, and it shows it on the article why, right? And then we could even, Volatility 2 doesn't seem to have that, but you could also done this. Grep, I could have done Linux version, probably this, and yeah, we get pretty much the same thing, right? Here, here. So either way, now done with Volatility 3. Let's follow these steps. So that's going to be our analysis. Let's look at build profile. Let's do this. So let's see. Kind of just follow these commands. It's going to clone volatility again. So let's see. All right. I'm going to clone it. and it wants us to go tools and Linux. Have a cd, volatility, tools, oh boy, tools, Linux. There we go. Right? You have this module right here. And then it wants us to do this. Replace, this one is doing it on, I guess, on the same kernel that they're on, and replace it with the default file. So we could do the same, and this is where the kernel version comes in handy. Right here. Place that. Alright. Pretty easy so far, right? And this is the part that I thought was very, very, very clever. You know, the use of Docker. And it's looking at 16.04, probably based on the kernel version at that moment. I need to run it with sudo, and it's building it off it's gonna save our current directory into a directory called Volatility, and ours is 20.04, and then set in the shell for us to use. See, so I don't have it locally, I don't find the image locally, so it just builds it, and there we are. Then we just have to install the essentials, right? It's just a simple command. Yeah, let's do that. No. Ooh, that would have been bad. I would have had to kill this. Linux image right there. So that didn't mess it up. There we go. Still not right. See, copy pasting is not always good. There. That should work. Yep, it's only 2 of them. Now we go into this directory and then we make. And then we have to do this command. Copy that. It's going to take some time, it seems. Then this is where how you would create the memory, the profile. We exit and we just copy right where the profiles would be. And that part is also covered in Admin Server 23, and it depends how you install Volatility, right? So now we're gonna do, what was it, cd go, yeah, okay, there we go. So now fix 2 things, create this, and then that, and we need that. We have, did I do that right? I don't think I did make. Right, let's see. No, I didn't do it. So let's delete that. Now we just have, for now we do make, okay. And then we run it. So make, there we go. Let's see, volatility modules. Alright, so we definitely messed something up. So sudo docker ps. Actually, so let's just run it again. Yeah, that's different now. So let's do this again. Make sure I do everything right. So copy that. And make sure copy everything correctly here. There we go. So that's that. There. So that'll go. We go into here, then we make, then we do this, and then okay. So gotta make sure I gotta pay attention, because otherwise you make an error, especially memory analysis. You make an error and you will pay for it greatly, as you can see. But the steps are pretty straightforward as long as you kind of catch yourself. So it's almost there, about halfway. Goes pretty fast. And let's see if this works. Almost there. Right. So we did this. Now we go into volatility and make. Right, yeah. Volatility, make. There we go. Did I not do that? Alright. What did I mess up? Definitely messed something up. Ability, docker run. Don't make zip. Yeah, everything looks good. Did I not do the Makefile right? Let's see, Makefile. Make. Oh, okay. Shell. Oh, I see. Whoops. There we go. That's probably what I did. So, said. I see what I did wrong. Copy this. That makes more sense. So I'm supposed to replace this right here. That's where the error is coming from. So there. And now we try it one more time. I have the command here. Yep, make zip. One more time. So I love Docker. You mess up, you could just exit and kill it and do it all over again. So let's see. It's gonna run. Then we go into volatility directory and then we do make. And there, should work. And this is honestly the trickiest part of the challenge. Is creating the profile and making sure you're properly doing what you need to do. And yeah, that looks good. Take some time. And it's very lightweight. As you can see, I'm wasting really no space. I'll still have like 23 gigs. So let's do this. Wish I got it right the first time, huh? That's what I get. And I think I showed it. Yeah, see, we're replacing this. And I think that's the only one. Yeah, see, this was the file we're looking for, the module.dwarf. And it's taking longer than I was hoping for, but it's not too bad. You know, let's give it a couple more minutes. In the meantime, let's see, I want to do that. There we go, let's look over this, see what else we can uncover. Okay, day 19. So again, if you're not too familiar with Linux volatility, I pretty much go over it, the commands here, and you know, basic analysis. So this is, we're hoping to end up with this. Let's see, there we go. Once I see the green, I know we're almost there. And and where to copy. See, mine, it's very dependent on the system that you installed. There we go, we're almost there. And there we go. Now, volatility, make. There we go, that looks better. There we go. Let's go back here. Did this. Let's do this right. And now make, replace this with this. There we go. Aha. And now here's the cool part. If I'm gonna make a new tab, I'm still on this directory. Everything that I did there happened here. So now we just need to copy it. And I'm glad I brought this back up again, because this is where mine is installed. So I just have to copy it, right? I'll double check here. There we go. Of course. Just make sure I actually copy it right. 2004. There we go. Ha. Copy. See? So a cool thing about this CSH shell is that it tells me if I'm right by the underline. See? So I'm going to copy it there. And this will vary per system, but it for me is off my home directory because I installed it as my current user. And now we're going to try this again and grep for, actually just run that again. Nope, that's not what I wanted. py. And if we go all the way to the top, the very first one is our profile. Now, moment of truth, did it work? I probably should have, I think I need to copy it. Don't need that anymore. Ubuntu. There we go. So let's see. It's volatility. F maxmem profile. Now, we could pretty much figure out how it works, but if you've kind of followed my examples here, you don't have to. Oh, okay, I might stop loading. Well, not enough right here. Linux underscore bash. Let's try that one. Don't need that anymore. Linux underscore bash. If we did everything right, hopefully we'll get some results. Okay, it's getting there. It's getting there. Parsing it, so that looks promising. Almost there. There we go. And you did it. So let's analyze what happened. Right. So we see there was this command run. So this is a plugin that parses the bash history file. So as we can see here, whoever the user was tried to sudo root, but instead of pressing enter, they typed their password. Classic typo squatting. It can happen to anyone. And if this is on your bash history file, I'm assuming that's the root password. You know, in a real life analysis, you would confirm with the user if this is the password. So if this was the attacker, then definitely, if they looked at the bash history, they saw this. Also, there's this database that was accessed, right? We see here the approximate time when it happened, the date. UTC, that's helpful, universal. So either the attacker saw this before or after they became root, and you can confirm with whoever is using the server if they actually used this command. Probably they did, but you have to assume that now the attacker definitely saw it because these commands are so close together. Especially the next command. See this? Shell, compiled it into this. There is a program called pkexec with 1C. This one uses 2C to kind of, and then they remove their shell. So they kind of use this to kind of try to remain undetected, and they executed it. Then there were some other commands, right? Change the password of the user. So this is the user, right? Restart. So some of these commands could be normal, and this is creating the profile, right? Not the profile, the memory dump, right? So we now have a kind of idea how the user actually maintain kind of when and see when. So these kind of happen right after the other, and then when they executed their actions. So let's go ahead and look at the processes. PS list. Right. It takes a while. See if that pkexec comes up. And let's see. It's not alphabetical order, so let's see. Does it come up? pkexec. It comes up there. No, it doesn't. Okay, look at that. But this one does. That's interesting. So it doesn't come up on the processes. Let's see. You can tell by the time when, if anything else happened. So let's see. This was 50, 50, 11, 17. So right around this time it seems. Say we have zoo here. Right, let's see. Split this into two. Bash. See if we can kind of view it in split mode here. Maybe we can get close. And then we'll see if we can find that file. Could be helpful. Timestamps are very important in analysis. Big fan of them. Oh, there we go. So let's go back up. 50. So it's 5011. Okay, so we're missing timestamp here. And let's see, 545. So we're missing a chunk right here, which is where I guess it would happen. Right. So is 5027. So okay, so they may not, this is why, you know, we get an approximate time. We can start kind of zeroing in. This could also have been the user. So now let's look at, what else can we look at? Let's end this. Let's see if we can find that file. Let's see, I think the one is enumerate files. Let's look at pkexec to look at shell.c. Okay, exact. There we go. This is an OR. And this one takes some time. It's parsing the entire system. And that's already there. Let's go back a few times. Because now what I want to do is extract it. So I'm going to do copy this. Utility, and I think this one's called Linux find file. And we need the inode value, which I'll get, and the output. I'm gonna call it. Let's see if we get this one first. Aha. So no inode valued for this. Can't recover it. But we have one for the binary. Let's see if we get lucky. And you won't get a result if it doesn't find it. Let's see. We could do a basic analysis. I'll use both Ghidra and just strings. So let's see. Oh, it's an ELF file. There we go. So let's see what we can find. Okay, compiling. Then say you have an IP address here. So this definitely looks like reverse shell. Let's see if this comes up anywhere. Threat intelligence. Alright, this pre-owned thing. See. Nothing. Perfect. Okay. So let's do a bit of, well, actually, now that we have an IP address here, let's actually do Ghidra up, start Ghidra up. You don't have to do this part. You could do it two ways if you want to find more. So we could do Linux netstat, grab that, and back to Ghidra, open up a new project, non-shared. Let's see, where is it? Profiles, Ghidra. Aha. Open up the little dragon and import file. See profiles, pkexec. This is what we want. Now I would like to analyze now. Yes. Oh, I said there we go. And there we go. We have kind of a little code here. See the IP address. This is the port right here. Right. It's a little basic reversing. See, let's look at this. See what we get. Shell. See, reverse, shell in C Linux. It looks like C, right? I don't know if this is it actually. Maybe this one? Yeah, that looks like our code here. More or less. Yeah. In it. Yeah, more or less. It looks like a basic reverse shell. Pretty cool. Let's go back. We see connections are established to this port, which we already kind of saw here. 1337. Let's see. What else are we looking for? And persistence. Common place for persistence processes. Like system processes. Let's see if there were any crons. Let's see, cron. Take some time. And if there are, let's go ahead and call it, I'll call it cron. Then the user will need the INO value as well. Okay, there's a coming. There's a service, that's always useful. Okay, we have one for root here. Cron root. There we go. Take some time and see kind of payload. There we go. And looks like there was a cron. So this is a typical. See if I can find something. Let's see. Backdoor Linux 4N6. Oh, it's gonna be a lot with this one. So typical backdoors for Linux. Authorized keys. Oh, it's T. Does this have bash? Yeah. So the bash RC file is commonplace, right? So that bash RC where you can place code, because it's essentially just a bash script, right, with instructions. So you can also confirm with whoever the analyst is if they have a cron. So this runs every minute and copies it from here into here, right? So that way, if something happens to the bash RC file, it's not very good cover because you could see this on the process happening. This is an easy file to find. But let's see if we can recover that. I don't believe we can, so that's okay. Because in this scenario, you would typically still have the server, hopefully, so you could just go back and find it. Profile, but at least we kind of can see the command here. So typically, attackers could also put reverse shells here, but this one's at least will run once and done. With reverse shells, you can kind of see if they're still there. And I just really wanted to show how useful volatility can be. Well, there we go. So we have a couple of RCs. Let's see if we can extract this one. Dash RC. See if we have some luck. Okay, looks like that's it. It's our user. Fun fact, that's the name of the lovebird the family has. Been with us for almost 20 years. Long life. Okay, we extracted. We have something. Nothing. Here's the interesting thing. There's data on here, right? Oh, we you can't see it. Strings, see? No. Yeah, it's just blank. So, you know, sometimes dealing with memory, things might get corrupted, things might not capture well, but that's okay. We are able to kind of at least figure out sort of what happened, you know, based on the history, how the commands run, IP address, we have ports, no, not standard ports. So that pretty much does this challenge. I really had a lot of fun making this room. Like I said, it really just spawned from the advent of cyber task I was doing, except I wanted to kind of throw a little wrench in there and just did not give you a profile. What would you do if, you know, if you have a memory dump with no profile? How would you go about creating it? And what I liked about this article is, oh, where'd it go? A Linux profile volatility. You know, what I like about this article, it also goes same steps for Volatility 3, right? With just slightly little bit different. See, but it's pretty much is the same technique, Docker, you know, and then it goes right to it. So I think that is very useful article here for Linux memory analysis. So anyway, hope you liked the video and the task. Feel free to comment, like, and subscribe, and see you all next time.